Hi, welcome to TechGene. Today I'm going to share about IP address here. Let's go into the agenda of the IP address. And what is an IP address and what are the parts of an IP address and subnetting, the range of IP as well as the versions of the IP address and also the types of IP address. Let's go into see each one of the topic here. First we'll see what is an IP address. Suppose, as we discussed in the previous sessions, if you want to identify your device or if you want to communicate to anyone over the internet, each one have an IP address. So to identify your device over the internet, we need an IP address, okay, which is a digital identity and also the unique address to identify your device over the network, okay. And we can also define its location over the internet, and this is a 32-bit address which represent in the form of dot decimal notation, and it also determines who and where you are in the internet by seeing the IP address. Okay, as we discussed, it's a 32-bit unique address, and the address space of the IP address is 2 to the power of 32, means those many IP addresses are available. And who assigned this IP? It is assigned by IANA. Initially, it assigned by IANA, and suppose if you take a connection from the internet provider, who gives the IP address? ISP, service provider. For example, if you have an Airtel connection, which is a broadband connection, who provides an IP address to you? Your Airtel service provider, who is an ISP. Okay, and it's represented in dot decimal notation. The range of IP is 0 to 255. It shows in the form of 0.0.0 to 255.255.255.255. Now, let's see what are the parts of the IP address. As we know that we have two parts of the IP address, which is a network part and host part. Let's consider this IP address 129.144.50.56, and this address belongs to class B, and I will let you know why this address belongs to class B in the upcoming slide. Okay, class B in the network part 129.144 belongs to network ID and 50.56 belongs to host ID. Okay, and we can also call it in different names. Network ID is also called as prefix or network address. Host ID is called as host address or suffix. What is network part? This is a unique number which is assigned by your network. It defines which class you belongs to. Okay, now it belongs to class B. And what is a host part? In this particular network, you are in this network, this IP is assigned to your device. Suppose I have 10 devices which is connected within this network, means within this network, suppose I have 6 devices or 10 devices which are connected, means each device, each host have a different IP, like 50.51, 52, 53, 54, 55, like that. So it means each host have a unique IP address within your network. Within your network, each host have a unique IP address. Okay. See, this is an IP address that you assign to each host. It uniquely identifies that your machine on your network. Okay, and this is not the same. This address is different for each and every device in your network. Next, we are going to see what is subnetting. Subnetting means we are going to divide one large network into smaller networks. Why we are doing this? To avoid traffic. Like uh, let's see, it's a subnet means network inside the network. Means one large network is divided into smaller network. Okay. Divide a single physical network into more than one smaller logical subnetworks. And the main goal of subnetting is to minimize the network traffic. Why we are doing this subnetting? To minimize the network traffic. And subnet mask is different, subnetting is different. How we are minimize, like how we are going to divide one large network into smaller network. How it's going to be happen? Normally, this subnet mask is a 32-bit address. Many people confuse this is an IP address. This is not an IP address, it's just a 32-bit address which is setting up, it is divide the network part and host part. In the host part, if all zeros belongs to host part, okay, and all ones belongs to network part. So as we see in the previous session, like or as we see in previous 129 dot, consider as we said that this address is belongs to class B. Okay, 50.6. Okay, and this is network part, network ID. Okay, this is host ID. In host ID, all zeros belongs to host ID and all ones belongs to network ID. Okay, this is the meaning of subnet. What we are going to do? We are going to distinguish the network address as well as the host address of your IP address. Okay. By using subnetting, we are going to divide a larger network into smaller logical subnets. Okay. Suppose if you take a class A, in class A by using the subnet mask, I am going to divide into smaller network. If subnetting is not there, I am going to use the given IP address 0 to 255. Only those addresses I am going to use. I can't use the remaining addresses. In order to get more subnets, we are going to use the subnet mask. Let's see the range of IP addresses here and how we are going to divide the range of IP addresses. This is going to divide into 5 classes, which is class A, class B, class C and class D and also class E. Mostly we are going to use only class A and B, C. Sorry, class A, B and C. The range of IP addresses are 1 to 127 bits. This address belongs to class A. 1.0.0.0 to 126.255.255.255. This belongs to class A. Here if you notice, we have mentioned only 126. Where is this 127 went on? Where it belongs to? In class B, it starts from 128. I will tell you in the upcoming session, in upcoming slide. And in this in the first byte, if I set first bit, it belongs to class A. And subnet mask, first octet of the subnet mask is full of ones, means it belongs to class A. These belongs to network part and these 3 belongs to host part. Okay, in class A. And in class B, the range of class B is 128.0.0 to 191.255.255.255. This is the range of class B, and first 2 bits of the first byte is set to class B. And in this, first 2 octets in the subnet mask is used as network ID, and remaining 2 belongs to host ID. Means all ones belongs to network part and all remaining zeros belongs to host part. Okay, in class C, it ranges from 192.0.0.0 to 223.255.255.255, and all ones belongs to network part and remaining all zeros belongs to host part. And in class D, the range of class D is 224.0.0 to 239.255.255.255. In this, there is no subnet mask, and in class E, 240 to 255. In this also, there is no subnet mask. Class A is used for governments and class B is used for medium companies. Class C is used for small companies. Class D is used for multicasting. Class E mainly used for experimental and also study, research and development. So mostly we are going to use only class A, class B and class C. Class D and class E is not useful. And let's see how the range of IP addresses, as we discussed in the last slide. In class A address, the first octet in the network portion is all set to 1. It means that it belongs to class A. In the 2 octets of the network portion is set to 1. It means that it belongs to class B. In class C, the first 3 octets of the network portion all set to 1. It means that it belongs to class C. Okay. Let's see, this is the IP address of class A, and we do have a public IP and private IP addresses, and we actually have a range of 1 to 127. Within this range, we do have a private IP address range. In this, 10.0.0 to 10.255.255, which belongs to private IP address of class A. This is not used publicly. It is only used within your local network. And as we mentioned, the first octet of the network portion is set to 1. It means that it belongs to class A. In the subnet mask, the first octet of the network portion is all ones, means 255. So here if you see how many network means network ID, I have in the first octet I have 8 bits. 2 to the power of 8 minus 2. It means that 128 minus 2 is equal to 126. Why I removed 2? The first address is used for initial IP and the last address is used for broadcast IP. So those two addresses are not used. That is the reason I got only 126 networks. Okay. And how do I got this host? The same thing. In the host bit, I have 3. Each octet have 8 bits. So 2 to the power of, in this 8 bits, here 8 bits, here 8 bits. 8 3 is 24. So 2 to the power of 24 minus 2. Same thing, the first IP and the last IPs are not used. These many hosts are available in my network. Okay. The same thing in the class B, we have a range of 128 to 191, and in this is the range of private IP address 172.16.0.0 to 172.31.255.255, and in this the first 2 octets of the network portion is set to all ones, means that 2 octets of network portion 255.255.0.0. And how many networks I have? 2 to the power of 16 minus 2. Okay. And here 2 to the power of 16 minus 2. Yeah. And in this class C, I have a range of 192 to 223.255.255.0 range. And in this, the first 3 octets of network portion is set to 1, which I have 255.255.255.0. And if you see the private IP, this is the range of private IP for class C. Normally, this address we can see it on our devices. In our local devices, like if you connect your router, we may see this IP address 192.168.0.0 to 192.168.255.255 range. And this is the networks that we have in this class C, and these are the hosts which is available in the class C network. And let's see the versions of IP address. Usually we know that we have only 2 versions, which is IPv4 and IPv6. This is the initial version of the IP protocol, which is the internet protocol, and this is the latest version of the IP internet protocol. And as we know, which is a IPv4 is a 32-bit address, we do have an address of 2 to the power of 32, which is 4 billion addresses. Around 4 billion addresses are available. And since we are connecting a lot of virtual devices like your mobiles, iPhones, iPads, and security devices, alarms, and printers, due to that, we are shortage of networks, and there is a depletion of IPv4 addresses because we have only 4 billion 294,967,000 addresses are available. So instead of depletion of IP addresses, where we have a shortage of IP, we are to overcome that, we have a IPv6 address, which is a 128-bit address, which we have 2 to the power of 128, means around 340 trillion addresses are available, which we have a lot of IP address which is available, where we can connect trillions, billions, millions of devices over the internet. Okay. And let's see the types of IP address. We have 4 types of IP addresses are available, which is public, private, shared, and dedicated. Public means which is assigned by your internet provider. Once you got an internet connection, suppose you got an internet connection from your provider like Airtel, they provide one IP address which is a public IP address to connect your network. Either that is static or dynamic. If they provide static, means it's a constant, it never change, that IP address. Dynamic means it have a like end life, one like a week or 10 days. Every 10 days, a month, or a week, it keeps changing the IP. That is the dynamic. And private IP, once you connect your router to your devices, where you can access the internet over the your network. So each device have a private IP from your router. This is only within the LAN. You cannot communicate outside the internet by using that particular IP. How it happen? Your device connect to your router and router connect to the internet by the assigned IP address from your service provider. Shared means some companies, they are using email sending servers, use the same IP address. Why they are using this? To cut down the cost. And dedicated means particular IP address is given. If they want to communicate to that particular single company, if you want to communicate with them, we need to use the private secure socket layer, which it is not an IP address, which it's an IP address. This is not a domain name. Okay. If you want to connect, you need to log in via FTP by the IP address instead of its domain name. And if you see here the difference between private and public, as we know, it's a unique IP over the internet. Private is used only within the LAN connection, and this IP address is not recognized over the internet. It's only recognized, this public IP is recognized over the internet. Over the internet, each device have a unique public IP. Who assigned the private IP? Your LAN administrator. And who assigned the public IP? Your ISP. And to create a private IP, to get the private IP, it's free of charge. And for each IP, this is a cost associated. Suppose if you want to get two IPs, you need to pay 2 IP address amount to your service provider, like 2 connection. And this address is only unique only within your LAN, like your devices which are connected to your router, only it's unique within your router's network. This public IP, this is unique globally. If you see the range, class A have 10 to 10.255 days range, and class B have 172.16.0.0 to 172.31.255.255. Class C have 192.168.0.0 to 192.168.255.255. As we know, the public IP class ranges class A, class B, class C, class D, and class E. And in the previous slide, as I informed you, we haven't seen this 127.0.0 address. This address belongs to class A and it is reserved for loopback address. It's only used for testing and local testing purpose, like every device like your computer have a NIC card. We can see whether it is functioning properly. Suppose your router is giving an internet connection to other devices, but your system is not getting an internet connection, and you have a cable which is connected from the router to your computer. Even you change the cable, but still it's not working. It's working with other computer, but not your computer. How can you check whether my port is working properly? To check that your TCP/IP stack is functioning properly, like your NIC card is working properly, we can use this IP address. How can you use? Open the command prompt and type ping 127.0.0, any range of 127, from 127.0.0.1 to 127.255.255.255. Any range of IP address in 127 you can give for ping. If you get replies, it means that the port is working properly. If you are not getting replies, it means that some troubleshooting is needed. Okay, that's all about for today's session, and I hope you like this video. Please do like, share and subscribe. Thanks for watching, and please do hit bell icon for upcoming videos. Thank you.